name is Luke Anderson, and I'm from the business development team at Amazon Web Services. Today I'm going to be talking about building your data lakes that cost less and deliver results faster. What we're going to cover today is do a quick explanation of how we define data lakes today at AWS, a dive into how to reduce costs of building a data lake, and then how to increase your performance, and then ultimately how to make sure that we're planning and evolving for the future. When we have finished this webinar, hopefully some of the things you've seen will spark ideas of how to build systems that will better enable your business. As there is an increasingly a recognition that businesses need to be more data-driven to enable automation and to enhance the decision-making of the business, now is a good time to rethink how to go about that. More and more, we see our customers moving from old legacy approaches of buying inexpensive data infrastructure, which often takes months or years to start getting results from, to start thinking to be more agile and nimble. To be truly business focused, we believe there are three ways they're beginning to think differently. The first is to start the projects with specific business outcomes in mind. Start backwards from the insights and actions you want, and then work backwards to a streamlined design. Number two is experimentation. Start with a lean design. Use just enough data to test your ideas. Use just enough services to test those ideas. The design of the system is to scale up capacity as and when you need it. So if you hit on a great result, you scale that one up. And the other ones that didn't work out can just be turned off. Think win quick, fail cheap. And finally, speed with agility and timeliness. Our customers are changing their markets. They're redefining what service levels and customer experience means in those markets. Much of this is that they move quickly. When an opportunity presents itself and the business wants to move on that opportunity, they think in terms of weeks to design and minutes to deploy. This gives a material advantage over businesses that will wait 6 months to get approvals to buy an appliance or more storage. We've had many customers here succeeding in Southeast Asia, especially in Singapore, where we have some great customers like Redmart and Grab, and a number of others that are fundamentally changing aspects of our daily lives as consumers. So traditionally, if you're doing an on-premise or traditional analytics, you very much likely have an architecture that looks like this, where you have a lot of duplication and sprawl, where you may have your structured data in databases, data marts, and ultimately maybe rolling up to a data warehouse of some sort. And you're also probably storing a lot of raw business data in traditional storage arrays. Then for the more advanced teams focused on analytics and machine learning, you probably have some Hadoop clusters, NoSQL databases to perform more advanced analytics. If we start to think about how to reduce cost and increase performance, this is the lowest hanging fruit, because one of the biggest costs reduction is to eliminate the multiple copies of data. And if you have an environment like this, it is quite likely you have a large amount of duplicate data. Another way to improve performance is to stop moving data around between arrays and different applications and focus and work from a central set of data that is going to give you the biggest performance improvement. The way we define data lakes here at AWS is that it's an architecture and not a solution, and it's an architecture that provides virtually limitless centralized storage capabilities and where you can then process the data where it lives. Some of the key attributes we're going to use to define this are: 1, we decouple storage and compute, which is both to optimize cost and optimize performance. Number 2, we're going to focus on getting the data in rapidly and transform it as quickly as possible into a format that you can actually use to deliver business results. Number 3, how to secure multi-tenancy, because ultimately you're going to have a lot of people wanting to use this data and platform, and it's got to keep your CISO and other security folks happy. Number 4, query in place, because that's going to be the most cost-effective and performant way to do it. And finally 5, schema on read, so you can rapidly iterate. AWS Big Data and Analytics Services enable our customers and yourselves to easily run any analytics workload, whether it be batch, ad hoc, real-time, IoT, and predictive analytics, and at any scale, whether it's gigabytes to terabytes to petabytes and even to exabytes, in a secure fashion at the lowest possible cost. AWS provides a highly scalable, available, secure, and cost-effective data store that lets you store data in its native format and easily extract value from your data. This is particularly true now that many customers see much of their new data created directly in the cloud, with Amazon S3 being the home to the vast majority of it. With much more operating experience and scale and a broader set of analytics services available than anywhere else, S3 and our portfolio of big data and analytics services is the clear #1 choice for you to build your data lake and analytics solutions with. By turning this into an architecture diagram using some common AWS services, you can now see what the outcome is on the screen at the moment. So starting at the bottom, you've got to get the data integrated with the platform, which means moving data that you can onto the platform where it lives. But then you've got to note you're probably collecting it from multiple different data sources, from third-party partners and even from on-premise equipment. So as you can see at the bottom, there are 5 services listed here. This is by no means exhaustive, it's just an initial view. The database migration service, which you see at the bottom left, or DMS, is not going to be covered today, but as with all of our services, detailed documentation is available on our website. The next two, the Snowball and Snowmobile, are our data ingestion and migration appliances. Snowball being the on-premise appliance, and Snowmobile is physically a truck that we drive to your data center, both of which is where you plug it into your source on-premise data stores, upload your storage. We then move that to our regions and input the data. The final two, Kinesis Data Firehose and Data Streams, will be covered later in this presentation. Then as we move up through there into the data lake foundational layer, which is where our object storage solutions of S3 and Glacier live. And then also at the data lake layer, we have the AWS Glue, which will help you transform the data to get it usable as quickly as possible. Then comes the analytics tools on top of that. And you can pick and choose from a wide array of analytics tools, both native AWS services to do things like data warehousing, big data processing, and interactive querying. But there's also a whole ecosystem of third-party tools and developers that both your data scientists and yourself can use. The key thing is to use the tool that you're most comfortable with, because ultimately you'll be on the hook to deliver the insights and answers that drive the business outcomes. So why do we choose S3 and by extension the Glacier platforms for the data lake? The first reason is unmatched durability, availability, and scalability. Because if this is going to be the core part of your business, it has to be rock solid and reliable. You've got to be able to count on that data as being permanent and solid and available for when you need it. The second one, the security, compliance, and audit capabilities are important. You're going to have business critical information and maybe even personal data in there. And even in certain industries, you're going to have to want to share this data with other organizations. So you have to make sure you've got very granular, airtight control of who can access what and when to make sure your compliance teams are happy. The third one, object level control at any scale to provide that very granular level of how you control not just access to your data, but what happens to your data, i.e. things like life cycling. Fourth one is you want to get quick business insights into your data, which I'll talk a bit about later. The methods and mechanisms to integrate the data, bring it in and create hybrid architectures. And then finally, it's all about partners. With a broad ecosystem, we have twice as many partner integrations as other leading providers out there. So now let's talk about once you start this journey, you can build a cost optimized data lake and how can you reduce your data lake costs. Just pause there for a second just to make sure the webinar is catching up with everybody, so we're all in sync. So the first thing you want to think about is data tiering, because one size doesn't fit all when it comes to data. First, you're going to have data that is very hot, needed to be accessed frequently, and where you need the highest levels of performance. These characteristics and requirements will drive up your cost base, primarily due to the highly optimized storage and compute platforms required. So not all your data will need to be stored here. Once that data in the hottest areas ages and cools, it can be stored on lower cost architecture that, with the right metadata and tagging, can enable things like automated lifecycling. For example, you'd want to keep your hottest data in EMR and Hadoop and in high performing processing services like Amazon Redshift. Then once it cools, apply lifecycling to lower cost tiers like S3 or S3 and frequent access, and then keep more historical data sets stored in Amazon Glacier. So this is the foundational area for controlling costs. The second area is processing data in place as much as possible to further enable cost reductions. Essentially, avoid having to move data around will save both on monetary cost as well as time costs to do so. This will enable multiple tools to share the same data sets, which is the biggest cost producer here, rather than moving to and fro and having multiple copies of data exist in each tool. So all our new common analytic tools like Amazon Athena, Redshift Spectrum, and Amazon EMR and AWS Glue can all process data in place on S3. Now we're going to start covering each one of these during the presentation. If your workload requires highly distributed processing frameworks such as Hadoop and Spark, Amazon EMR might be the tool of choice. With EMR, you can decouple compute and storage, which means you can 1. Shut down EMR clusters with no data loss, right-size EMR clusters independently of storage, and 3. Have multiple Amazon EMR clusters running concurrently. It is ideal to compress your dataset using standard compression algorithms such as gzip, LZO, and Snappy. Each of these have their pros and cons with respect to splittability, compression ratio, and compression speed. For example, gzip is not splittable, has high compression ratio and medium speed, compared to Snappy, which is also not splittable, has low compression ratio, but is very fast. Also, to achieve faster performance, columnar formats and aggregating small files to larger objects will result in the best performance. You will notice that irrespective of which AWS querying tool you choose, aggregating files into larger objects is integral to reducing costs. Few benefits of having larger files are faster listing, fewer S3 requests, and less metadata to manage. There are also a number of other considerations, such as using spot instances, where you can save up to 80% of your compute costs for running the clusters. And then finally, use elastic scaling, so you can scale up and scale down to meet demand. This would enable you to spin up multi-clusters, segment your analytics workloads, and fundamentally run them from one data store on S3. Next up is Amazon Redshift Spectrum, which is a tool that allows you to run Amazon Redshift SQL queries against vast amounts of data in your Amazon S3 data lake without having to go through tedious and time-consuming ETL process. Amazon Redshift Spectrum applies sophisticated query optimization and scales processing across thousands of nodes to deliver fast performance. Some of the recommended practices that can help you optimize your concurrent workload performance using Redshift are: the first one is data warehousing with hundreds of terabytes of data. The restore process can take a long time and result in data latency issues. With Amazon Redshift Spectrum, you can move the largest tables to Amazon S3, and each Redshift cluster needs to keep only a small amount of that data on local disks. Because of that reduction in data volume, it would be much faster to spin up or restore multiple read-only Amazon Redshift clusters to handle these seasonal spiky query workloads. Similar to EMR, Amazon Redshift Spectrum reads only from columns of a file that are needed for the query. So Amazon Redshift Spectrum charges you by the amount of data that is scanned from the S3 per query. An example of a columnar format is Parquet that stores data in columnar format, so Amazon Redshift Spectrum can eliminate the unneeded columns during the scan. And the third one is there are certain SQL operations that can be pushed down to Amazon Redshift Spectrum layer, and you want to take advantage of these wherever possible, such as the group by clause, certain string functions, common aggregate functions such as the count, average, sum, min, etc. Moving on to Amazon Athena. Amazon Athena is our interactive query service that makes it easy to analyze the data stored in Amazon S3 using standard SQL. Athena is serverless, so there's no infrastructure to manage, and you only pay for the queries that you run. Simply point your data in Amazon S3, define your schema, and then start querying using standard SQL syntax. Compressing your data can also speed up your queries significantly. As long as the files are of an optimal size, all the files are splittable. Now, splittable files allows Athena's execution engine to split the reading of a file by multiple readers to increase parallelism. If you have a single unsplittable file, then only a single reader is able to read the file while all other readers sit idle. For Athena, we recommend using either Apache Parquet or Apache ORC, which compress data by default and are splittable. When they are not an option, then you can also try other third parties such as bzip2 or gzip with an optimal file size. Queries tend to run more efficiently when reading data can be parallelized and blocks of data can be read sequentially. Ensuring that your file formats are splittable helps with this ability to run them in parallel, regardless of how large your files may be. However, if your files are too small, generally less than 128 megabytes, then the execution engine may be spending additional time with the overhead of opening S3 files, listing directories, or getting the object metadata. On the other hand, if your file is not splittable and the files are too large, then query processing waits until a single reader has completed reading the entire file. That can reduce parallelism and also performance. So we recommend a larger block size if you have tables with many columns to ensure that each column block remains at a size that allows for efficient sequential I/O. So we've talked for the last few slides, we've talked a lot about using the right data format like Parquet or ORC or some sort of other columnar compression format. But if you've got a streaming type workload or you're doing a lot of log diving like security analytics, it may not be feasible to use these formats. So at Amazon, we focus on putting more intelligence into the storage layer. So if you can't use any of the formats we've previously discussed, there are other ways you can do this, which we'll discuss a little bit later. Some of the tools that we just discussed today retrieve the entire object from S3 or Glacier, even if you only need to pull a small piece of data out. Traditionally, you always restore a block of data and then the analytics tool scans all through that data and then only chooses what parts of that data they need to run any further queries or generate some insights. And it's just the way traditional storage platforms worked when they were coupled with analytics tools. So as I mentioned, at Amazon, we've been investigating how to do this. How do we move more intelligence down into the storage layer? So what I want to talk about now is Amazon S3 Select and Glacier Select, which you may have seen released or mentioned at reInvent last year and GA'd earlier this year. Now, with Select, both S3 and Glacier Select, it allows you to perform SQL expressions to select a subset of data from an object, which is a much more efficient way than retrieving the whole object and having the analytics tool run that scanning and filtering. So what was the motivation around this? So we just discussed Amazon Redshift Spectrum and how you could query data directly from S3. But if you look at a live customer example of using Amazon Redshift Spectrum, they ran 50,000 queries, which fetched 6 petabytes of data from S3 to run those queries. But when we looked at the actual amount of data used by Redshift, it was 650 terabytes. So roughly 10% of the data was needed. So think about a model where you could intelligently push down to the storage layer the ability to do that data scanning there and only return the results that Redshift Spectrum needed. Number one, that's going to greatly reduce Redshift Spectrum scan cost. But number two, it's going to greatly increase performance. So this is one of the main drivers around implementing and launching S3 and Glacier Select. So what is it? So essentially, it allows you to select a filtered set of data from within an object using a standard SQL statement. So it's the first content-aware API within the Amazon S3 family. Unlike Athena and Spectrum, it operates within the S3 system, where the S3 system is doing the data scanning and data filtering work. It operates on a per object basis, not across a group of objects. So it's not a replacement for Amazon Athena or Redshift Spectrum or even EMR. And it's important to note, it doesn't change some of the other characteristics of how S3 works. It's just an additional enhancement to the existing APIs, SDK, and CLI. So who's going to use this? I mean, obviously it's a great plugin for Amazon Redshift Spectrum, Athena, and EMR, and other custom query engines where it can optimize and reduce the cost and improve their performance. But ultimately, if you're a data scientist, you can go and use this directly either through the SDK or CLI and do things like diving into logs or querying logs without having to spin up a separate service to do it. The way it works is you specify your input, which are the files that you want to do and perform the select on. And today we currently support CSV, TSV, JSON, and gzip. And then issue SQL statements consisting of select from and where against those objects. And then you get the output of the data that's within that object that matches all of those conditions in the SQL statement you issued. One feature of S3 Select and Glacier Select is you can change the input and output format. So you could start with an input format of CSV and have the output format in JSON. So think about if you want to get an object and do a pattern match. Today, what you have to do is essentially get the object, write some sort of function which could run on Lambda, and you then have something external to that to then perform the filtering and running more of the select statements and getting the data you want from it. Or with S3, what you essentially do is select the object, give your statement, and S3 is going to return the result without needing any external filtering or external computation to do so. You can also apply this with AWS Lambda, which is our serverless compute platform, and start to do things like Lambda triggers to go and do the S3 select operations against the objects in S3 and return the outputs. So now you can start really using this to integrate with some of your existing applications today. So what you should see loading up onto your screens shortly, where there might just be a little bit of a lag, you'll start to see something onto the screen, which is an example of something one of our solution architects wrote that essentially enables you to do serverless MapReduce. If you look on the left, this is code where you could use our Lambda platform to do serverless MapReduce and the actual data scanning as well. But then on the right, by plugging into S3 Select, we essentially push that scan and data selection work down to S3. So you can see the difference between the before and after S3 Select made this capability. It moved it to be 2x faster at 1/5 of the cost. And now with all live presentations, I am going to try a quick demonstration by showing a video. I have sort of cheated on this one, so apologies. These are recorded demos. Hopefully you can see the screen that's just popped up. Again, this is an example that's been written by one of our solution architects. Just to make sure I've got the right one here. So essentially it's doing a query against a CSV file which contains airport codes. Now this first example that you're going to see is just a general listing with using standard S3 and then S3 Select. So this was a live recorded demo. And the results aren't coming through, which is always, there we go. So as you can see on this one, without S3 Select, it was 1.89 versus with Select 0.32, which shows an 83% improvement. But let's get a little bit more granular in there, using exactly the same data set, but now we're being a little bit more specific. We're searching for the LAS airport code, which you hope you can see on my screen here. So we're looking for LAS airport code in both. And here the difference is without S3 select, it was 2.05 seconds versus 0.27 with S3 select, which shows a 77% improvement. Now, obviously, this is a very basic example, but it gives you the idea of how using S3 select directly through command line interfaces, you can start achieving some significant benefits. So as I mentioned earlier, the S3 Select has a Presto connector. So it works with your existing Hive metastores, which is typically what is used with EMR Hadoop, and then can automatically convert the predicates into S3 Select request and then pushes it down. So another example here, once the screen loads up, just give it a bit more time. So this is an example of a Presto connector before and after scenario of running a specific query on the left versus the S3 Select Presto connector on the right. Now, what it's showing here is the before and after. It was a 5x faster at 1/40th of the CPU. So it's a big game changer in terms of accelerating your big data requests and performance, and also reducing the overall processing requests, generally from the number of queries and also the amount of computation required to run those queries. Just pause there for a second just to make sure this screen finishes loading up. So moving on to Glacier Select. Now, Glacier Select is even more interesting because Glacier, as I mentioned, back in that tiering of your data to reduce cost, is where the colder tiers of your data are stored, also at a much lower cost. Now, the need here, so where we also introduced S3 Select, we also introduced Glacier Select, where you can use the same SQL query to do SQL statements against the data that's archived in Glacier, where Glacier will filter that data, restore the output that matches those statements into an S3 location, and notify you that the data is ready to use. So all the richness that we've just discussed about S3 Select can now apply to your archive data in Cold Archive as well. So on to the next slide, how it works. This is just a process workflow of just showing what I just described a minute ago. Where using the Glacier-Select command line interface, you basically select what part of the data you want from the Glacier Vault. Glacier Vault will then go and hydrate that data, perform the query, make the data available in an S3 location, and then notify you using Amazon SNS that that data is now ready to be used. So without having to spin up any computation or other analytic services or do any of the hydration of the data yourself, Amazon Glacier Select will actually do this for you. So that's some of the common ways you can reduce costs. I'm going to switch gears now and talk about how you can deliver results faster. But ultimately, if you're going to turn this into data into business value, the quicker you can turn it into those outcomes, the bigger the competitive advantage you're going to have. So let's put this all together. If you're looking to optimize performance on your data lake, there are 3 things you should look at. The first, it is recommended that you aggregate small files into creating larger objects so that your requests costs go down. You get faster listings and you have less metadata to manage. Your goal should be to aggregate files to be more than 128 megabytes for best results. And you can do so by using the Amazon EMR S3 disk CP group by function. Or if you have a streaming or IoT type workload, Kinesis Firehose comes in very handy to be able to consolidate small files and putting the files on S3. Number 2, we just discussed S3 and also Glacier Select, which is a capability within our object storage framework that enables big data applications to run up to 400% faster, depending on the type of query, and also much cheaper by retrieving only the amount of data that is required for a particular query, instead of retrieving the whole object. So it reduces costs, obviously, from reducing the number of queries, and the time as well, because you're only getting the data back that you need. And third, another way to achieve faster query results is by formatting the data. Columnar formats such as Parquet and ORC are used to reduce costs, thereby reducing cost and performance. There is another feature within EMR called EMR FS Consistent View. And if you enable this feature, you can be confident that all your files will be processed as intended when you run a change series of MapReduce jobs. The EMR FS Consistent View creates and uses metadata in an Amazon DynamoDB table to maintain a consistent view of your S3 objects. This table tracks certain operations but does not hold any of your data. The information in the table is used to confirm that the results returned from an S3 list operation are as expected, thereby allowing EMRFS to check list consistency and read after write consistency. Just pause there, just to make sure the keeping up to date and in sync. So Amazon Kinesis. So Kinesis is essentially a streaming tool which is focused on real-time streaming workloads, and it's all about collecting, processing, and analyzing data streams in real time. Now, with the addition of Kinesis video streams on the left, you can now easily process and analyze video streams and data streams on AWS. Kinesis video streams lets you use video, audio, and other time-encoded data to build applications that power robots, smart cities, manufacturing automation, security monitoring, and machine learning. Kinesis streams, which are now called Kinesis data streams, enables you to build custom real-time applications using popular streaming processing frameworks of your choice. And then moving further to the right, Kinesis Firehose, which we're now calling Kinesis Data Firehose, makes it easy to collect and load data into streams. And Kinesis Analytics, which we're now calling Kinesis Data Analytics, makes it easy to process and analyze these data streams in real time with SQL. Another key element to focus on when you think about delivering results quicker is around how you can reduce the time it takes to prepare your data before you can actually run analytics against that data. A recent study by Crowdflower, who surveyed about 80 data scientists about their jobs, they found that data scientists spend approximately 60% of their time on cleaning and organizing data. Collecting data sets comes in at second at 19% of the time, meaning data scientists spend around 80% of their time on preparing and managing data for analysis. They also found that data preparation was the least enjoyable parts of their work, and I don't blame them, to be honest. So the key question we have to ask ourselves is, if we can make data preparation easier, can we minimize the time that people are collecting data sets and cleaning and organizing data? I mean, ideally, freeing up 80% of their existing workload. So this is where AWS Glue comes in. AWS Glue is a fully managed extract, transform, and load, or ETL service that makes it easy for customers to prepare and load their data for analytics. You can create and run an ETL job with a few clicks in the AWS Management Console, where you simply point AWS Glue to your data stored on AWS, and AWS Glue discovers your data and stores the associated metadata in the AWS Glue data catalog. Once this has been cataloged, your data is immediately searchable, queryable, and available for ETL. AWS Glue generates the code to execute your data transformations and data loading processes. Glue generates Python code that is customizable, reusable, and portable. So once your ETL job is ready, you can schedule it to run on AWS Glue's fully managed scale-out Apache Spark environment. One thing to note out here is AWS Glue is completely serverless, so there's no infrastructure to buy, set up, or manage. it automatically provisions the environment needed to complete the job at hand. And you as customers pay for only the compute resources consumed while running that ETL job. And then with AWS Glue, the data can be made available for analytics in minutes, depending on the size and type of job you're running. So some of the key characteristics of AWS Glue, the first is it's easy. AWS Glue automates much of the effort in building, maintaining, and running ETL jobs. AWS Glue crawls your data sources, identifies data formats, and suggests schemas and transformations. Glue also automatically generates the code to execute your data transformations and loading processes. The second, AWS Glue is integrated across a wide range of AWS services, such as Amazon Aurora or Amazon RDS. Amazon Glue provides out-of-the-box integration with also Amazon Athena, EMR, Redshift Spectrum, and any Apache Hive Metastore compatible application. So pretty much many of the services we've discussed earlier in this presentation. The third is sort of repetition, but it's serverless. Again, there's no infrastructure to provision or manage. And then finally, it's developer friendly. So AWS Glue generates ETL code, as we said, that is customizable and reusable and portable, but using familiar technology like Python and Spark. You can also import custom readers, writers, and transformations into your Glue ETL code. Since the code AWS Glue generates is based on open frameworks, there is no lock-in and you can use it anywhere. Now, as we start getting deeper into it, and as we start observing more of our customer behaviors and how our customers are using data, it has been observed that people are starting to look into machine learning in a little bit more detail. And what we have seen is it can be a very time-consuming process to build, train, and deploy models. And not only that, it takes a lot of specialized expertise to be able to do this. So this is where we've introduced Amazon SageMaker. That is a fully managed service that enables developers and data scientists to quickly and easily build, train, and deploy machine learning models at any scale. SageMaker removes all of the barriers that typically slow down developers who want to use machine learning techniques and capabilities. So one of the key things that we're doing with SageMaker is to remove that complexity which is holding you back from using machine learning techniques. And we've identified there are 4 main features or areas to focus on with SageMaker. And the first is the end-to-end machine learning platform. So Amazon Ironman offers a familiar integrated development environment that you can start processing your training data set and developing your algorithms immediately. The second one is zero setup. Amazon Ironman provides hosted Jupyter notebooks that require no setup. So you can begin processing your training data sets and developing your algorithms immediately. The third one is flexible model training. So with native support for bringing your own algorithms and framework models into Ironman provides a lot of flexibility. So at the moment, Ironman provides native Apache MXNet and TensorFlow support and offers a range of built-in high-performance machine learning algorithms in addition to supporting popular open source algorithms. And then finally, it's pay by the second. With Amazon Ironman, you pay only for what you use. Authoring, training, and hosting is billed by the second with no minimum fees and no upfront commitments. So those are just some of the common ways to improve performance of your data lake. Ultimately, we're looking at optimizing the end-to-end workflow, how to build your data pipelines, and get your data ready to process in the quickest possible way. But ultimately, this is always going to be a journey. So another key factor in building the data lake in terms of reducing costs and improving performance and agility is to plan for the future. And this is where building a data lake on a platform like Amazon S3 gives you a big advantage, because you can evolve it by utilizing a whole host of tools out there, some of which we've just discussed. These tools allow you to experiment with the underlying data sets collected and increase agility in your analytics process to ultimately deliver insights and answers in a far more cost-effective and performant way. And this, as we said, the last few minutes has been spent very much at a high level of how to build your data project in AWS to reduce costs and deliver results faster. There is a wide range of training, online training, available on our www.aws.training website, where you can start looking at big data, get more details on Amazon Redshift Spectrum, Amazon S3, or even Amazon S3 Select, with the relevant certifications as well. And finally, I just wanted to say thank you for joining today. I do hope this has been helpful in letting you know a few ways that you can get better results more quickly and for less cost.